Hello, everybody. I'll give it a second for everyone to join on in, and we can go ahead and get started. What is up, Luke? How you doing, man? Happy Saturday to you as well. Honestly, though, it's not really a happy Saturday. I'm a little sick still. Still coughing it up a little bit. So I'm gonna keep my voice a little bit lower today, so I don't make it worse. But yeah, let's give it 1 or 2 more minutes, and we can go ahead and get started. Let me open up my second one as well, just in case chat does not work. All right. Cool. So I think we're good to go ahead and start. We're here on CodeWars doing what we do. Sorry, not CodeWars, REPL. I've got my CodeWars open here, and let's open up a REPL for the CodeWars just in case we need to do some tinkering. We can do that here. Hello, Maria. How you doing? So before we continue with our CodeWars, I really like CodeWars, honestly. Let's just talk about some of the functions that we've been exposed to so far. In our first little run with CodeWars, we had the ABS function, sum function, .replace, .count, .join. And let's actually go through and review these first so that when we approach our next set of CodeWars problems, we're equipped with this arsenal of methods and functions. We also have the sorted function, the map function, the enumerate function, the .upper string method, and the .lower string method. I'm doing all right. I told Luke I'm feeling a little sick still, just from last time, but it's okay. I'm doing all right. So yeah, let's start off with our function review. As always, we'll do our ABS function. So this ABS function stands for absolute value. That's basically what it's used to do. So if I have two numbers, let's say we have a positive number, we'll make that 10. And then we have a negative number, make this a little bit bigger. If we have a negative number, we have that negative 10. Again, if I print the ABS of my positive number, I get 10. If I copy this, bring it down here, paste the ABS of my negative number, I get 10 two times. So what is ABS doing? ABS is an absolute value. So you've probably seen it in math. It looks like these little bars right here. Where's my comma? Oh, there it is. So it looks like this. Your little number in here. What this does, it takes any negative number or any positive number and just makes it positive again. So that's our ABS function, our absolute value function. Next, we have our sum function. Now, this is pretty self-explanatory. There's not really a meaning to the name. But what it's used for is if we have, a bunch of scores of our students, right? Student test scores, right? We're gonna do 60. We have an 89 in there. We have a 90. Someone got 100. Someone got like an 85 or an 86. So I have all of these test scores, right? And I want to find the average of them. Find the mean, the average. To do that, I have to add all of them up. I have to add all of them up and divide by the length. How can we do this? Well, we can say sum of student scores equal to the sum of the student scores list, or iterable, right? If I come down here and I print sum of student scores, right? Run that, I get 425. So what is that doing? That's adding up the 60 and the 89. So that's 149. 149 plus 90. Okay, I got to pull my calculator for this one. So we have 60 plus 89. That's going to be 149 plus 90. That's 239 plus 100. That's 339. And then plus this 86, we get 425. So we've basically added up all the numbers in this list. And then I can say, well, the length of student scores, because again, we have to take the sum of everything and then divide it by the number we have, is equal to the length of the student scores list. We print out the length of student scores, we get 5. Cool. So yeah, this is 1, 2, 3, 4, 5. Finally, we can just say the average score is equal to the sum of the student scores divided by the length of student scores. All right. We print that out, average score, we get 85. So an 85 is the average score out of all of these student scores. So that is our sum function. Now let's take a look at this dot replace string method. Dot replace string. One second. So dot replace string method. So let's say we have a string. We're going to call this test. Okay. My name is John. Okay. And what I'm actually going to do is everywhere there's a space, I'm just going to replace it with an asterisk, like that. Okay. And my goal with this, to use my dot replace string method, is to make this print out normally, like it look like a normal sentence. So what I can do is I can say print test dot replace. What am I replacing? I'm replacing these asterisks, and I'm going to replace them with spaces, right? Print that out, I get a nicely formatted string like that. Pretty straightforward. So that is our dot replace string method. Let's look at our dot count string method. Again, let's keep this this layout. Now what we're going to say is, hey, I want to know how many asterisks I actually have in this string. We can say test.count the number of asterisks. And we can safely assume that, well, there's 1, 2, 3 asterisks, so we should hope that the print statement yields 3 as well. Bingo. That works just fine. Now, sorry. The last string method that we touched upon in the previous lesson before the review was the dot join string method. And this one was a little bit more interesting. Dot join string method. Now, what you could do with this is we take an iterable. Let's just say we have parts of sentence. That's the name of my string. Sentence, right? We'll say, hi, my name is John. Like that, right? We want to print it out into this nice string, just like we did last time. So basically, what my goal is that I want to take all the parts of my parts of sentence list and then combine them into a big string. Well, let's use our dot join method. So we'll do space dot join parts of sentence. There we go. It's a nice string. So what happened? Basically, our dot join string method say, hey, I want Python to take this empty, not this empty string, but this space, right? And I want it to put it between all of these parts of the string and turn that into a big, into a full string. And again, I can put like asterisks in here as well. How they've been combined together with asterisks. I can put in like a whole thing like that. They've been combined with that whole thing. So it's pretty interesting and pretty powerful. All right. How many functions do we have left? We have 3 more functions and 2 more string methods. So sorted function. Sorted function. Again, pretty straightforward. I'm going to try to go quicker on these ones because they're pretty easy. Let's just say we have numbers. Actually, let's stick with our scores, okay? 100, 54, we'll have an 89, we'll have a 20-something. Terrible scores, but let's say we want to print them out in order. So just say printed sorted scores. Just like that, 20, 54, 89, 100. They're now in order. If I wanted it from going from highest to lowest, right, because it's going from lowest to highest, all I have to do is pass in another argument, reverse equals true. True. We go 100 all the way down. Pretty straightforward. Now what we're going to do is we're going to look at this map function. So what this map function was doing was basically you take a function and you can apply it to several elements at once. What do I mean by that? Let's say we have a bunch of numbers. Let's just stick with, I'm just going to call them numbers, okay? And right now they're all strings, right? All strings just like that. We'll go up to 5, okay? What if I wanted to turn this? Oh, I apologize. Let me rewind a little bit. I was going a little fast. I apologize. Did you get the, oh, dot join. Okay. There we go. And let me just make this look normal. So there you go. You have basically the string that you want to combine all the parts together, and then you give it the list that you're combining. I apologize for going too fast. I'm sorry. Just let me know when you got it, and then we'll move on to the sorted function. All right, let's take a look at the next one. Command Shift C, was that it? Control Shift C. Or I redo. I'm just gonna do the whole thing again. All right, so we have scores, right? Just an iterable, say 90, 100. We'll have a bunch of numbers out of order, basically. My goal is I want to put them into order. So again, this is the sorted function. So what we can say is sorted scores is equal to the sorted function being applied to the scores list. And if I print out the sorted scores, I get 2, 54, 90, 100. They're all in order now. Now, let's say I wanted it going from the highest to the lowest, right? 100, 90, 54, 2. All I have to do is apply this reverse argument and set it to being true. So now we're going from the highest to the lowest. So, you know, by itself, the reverse is defaulted to false. Again, if I do that, we go this way. Just let me know when we're good to move on. So default is false. So if I get rid of this, it stays the exact same. So by default, reverse is set to false. If I bring it back, same thing. So when I set it to true, that's when I can go from highest to lowest. Like that. So default reverse is set to false. come down here and start setting up the map function. Got it? Okay, good. Clear this then. We have our map function. Basically, the map function is used to apply a function to several things at once. Now, let me give you an example. Let's say we have a list called numbers, right? And it's just a bunch of strings, right? 1, 2, 3, 4, 5, right? Just like that. The chat isn't working. Okay. Oh, yes. Go ahead. Go ahead. Do I need to add reverse is equal to false since it's default, or can I add only reverse? So again, since it's defaulted, you don't have to necessarily add it. So let me head back to that actually. Whoop, 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 whoop. Actually, yeah. Again, if your goal is to take these numbers and have them go from lowest to highest, then you don't need to set this reverse to being true, right? Because it still goes from lowest to highest without having to set it, because it's defaulting to false. But once I set it to true, right, that's breaking the default. Then it goes from highest to lowest. So again, since it's default, you don't have to add anything unless you're actually trying to make it go from highest to lowest, or you're trying to flip how it's being sorted. Because again, this works perfectly fine without setting that. Is that good? Awesome. Awesome, awesome, awesome. All right, map function. Map function. Again, we have a bunch of I'll just make it nums. 1, 2, oops. 3, 4, 5, right? Let's say I want to go through all of these numbers and square them. What does that mean? That means I want to go through and I want to do 1 times 1. I want to do 2 times 2. Oops, 2 times 2, 3 times 3. I basically want to square them. So again, I can't do that because these are strings right now. I have to turn them into integers. So what I can do is, again, first let me print out nums right now so we can see it's all strings. As you can see, all strings. Now, what I'm going to say, I'm going to make a variable called int nums. That basically just means the integer version of these numbers. I'm going to set that equal to the map of the int function to nums. Now, if I print this, print int nums, get this, it's a map object, so it doesn't really make sense for us. So what we actually have to do is we have to wrap this within a list function to turn it into a list. So if I do that, we see I have all of these as integers now. So let's ignore this list part right now. Let's just focus on what this map function is doing. Basically, what I'm telling Python to do is, hey, Python, take this int function, right? Because I want to convert all these to integers, and just apply it to all of the numbers. So again, a for loop sort of equivalent of this would be if we had like an empty list called int nums like we do above. We're going to go through, oops. We're going to go for number in nums, int nums dot append integer of number. So this and this are doing the same exact thing. Because again, I'm going through all the numbers, right? I'm going through this one, and I'm going to apply this int function to it. And I'm going to add it to my int nums list. Next, I'm going to take this 2, I'm going to apply my int function to it, and then add it to my int nums list. Same thing here. Going through each of the numbers, turning them into integers, right? Mapping this integer function to them, and then saving them to this list. So again, we have our list of int nums. So now we can say for int num in int nums, print int num, and we're going to square it. Boom. We've basically gone through. So what we've done here is we've taken a list that is consistent of a bunch of strings. We've gone ahead and we've turned all of these strings into integers. And that would allow us to go through each item in the list and then square it, and then print that square out. So how do we feel about that, folks? And again, I'll give you guys a second to copy down the example. Do the example with squaring the numbers. What do you mean by that? This is because that's what I'm doing here. Turning them all into integers and then squaring them. Or do you want me to like explain it one more time? Oh, yep, right down here. Well, so Maria asks, so the purpose of mapping is to convert from strings to ints and ints to strings. Not necessarily. The purpose of mapping, and here I'll write this down as well, is to efficiently apply a function to an iterable. Actually, now that you asked that, let's actually iterable. So let's actually continue using this example. So what are we doing here? We've gone through each number, and we're going to print out its square. So we're able to efficiently apply a function to an iterable. So that's any function, even a function that we create. So what I'm going to do is I'm going to create a function called square number. And this is going to take a number, okay? And again, I want to apply this function to this nums list. So each of the items in this nums list, they're going to be strings, right? So the first thing I want to do is convert my number to an integer. So int number is equal to the int of number, right? And all I'm going to do is just return int number, and I'm going to square it, right? So here, let me comment this out. Let's test this out. Let's say I say r is equal to square number. I'm going to apply a string 4, right? If I print out r now, I should hope to see 16 as an integer, right? And again, just to prove to you guys it's an integer, we'll put on type r. See, it's class integer. Perfect. So now I want to efficiently apply this function to an iterable. Well, we have an iterable right here. It's our nums list, right? We'll print that out. So what I'll do is we'll make another list. We'll call it squared nums. That's going to be where we map this square number, the nums list. Okay? We're going to take all this function and apply it to every item in here. And then we're going to convert that into a list. If I print out squared nums, look at that 1, 4, 3, 1, 4, 9, 16, 25. So I've taken all these as strings, right? And then I've turned them into integers. So this 1 became an integer. And then I multiplied it by itself. So 1 times 1 is 2. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So any function, even user-defined function, I can apply to iterables using my my map function. Again, it's so much easier than having something like a for loop, right? To have to go through each item one at a time. You can just define a function, apply it, one line, good to go. It's awesome. I haven't looked into like performance if it's actually faster than using a for loop. But that's definitely something worth exploring. If it's faster to use a map than it is to use a for loop. But are we all okay with this? How I've defined my own, user-defined function called square number, and how I'm able to apply it to this nums list, to every item in this nums list, and then print that out. All good? All right. I'm not seeing any questions. I'll give you guys just a minute or two to copy this or add any comments that you guys are, any comments you guys are adding. And we can go ahead. I think we're going to end up spending most of this this lesson just reviewing these old functions because again, we went over so many so quickly. So again, definitely things worth using when you're coding by yourself. But we only have a couple left, and they're pretty straightforward. So it looks like I'm good to go ahead and just clear this out. Yeah, sorry, the chat is being a little buggy for some reason. There's nothing I can do about that. We're just gonna have to bear with it. But I'm gonna go ahead and clear this. And now let's take a look at our enumerate function. Enumerate function. So again, these are all working with iterables. Actually, let's have names. All right, let's have student names. We need another list. And actually, let's make it a tuple. We've been doing a lot of stuff with the list. Let's show some love to our immutable, iterable brother, the tuple. Again, we'll put Maria in here, Luke in here, me in here. Now, if I want to do for name in names, print name, we know what to expect from this, right? It's just going to go print Maria, Luke, and Varun. Now, if I take this section of my for loop, right, and I wrap it in an enumerate, right? Enumerate. But basically, if I print name now, I get an index and the name of the person. So again, Maria is at index 0, so 0 and Maria. Luke is at index 1, so Luke 1 and then Luke. So what I can say is for index, comma, name and enumerate names, print index and name. Now, I don't really have an example that I can think off the top of my head to make this useful, but I'm pretty sure the last one we used this, it was basically a CodeWars game where you had to do like A, and it was like B, and it was like C, D. Do you guys remember that? It was something like this. I can't remember if it was the review lesson or the main lesson from last week. But basically, the pattern that we found was that the number of lowercase letters, number of lowercase letters is 0 for the first one, 1 for the second one, 2 for the third one, and 3 for the fourth one. So it was yeah, Maria was there. Yeah, she knows. But basically, these sort of correspond with like general indices, if you will. So that's how we use this section. Again, hopefully we'll get to use it, but I don't really have an example that is like good or like makes sense. So for the enumerate function, just have it, somewhere in your memory. We'll probably get a chance to use it later on. So I'll give you guys a second to clear that out or to copy that down. I'm going to come down here and let's take a look at the dot upper string method. Upper string method. Yeah, it has its use cases, but again, I can't like show a nice example like what I did with the map function. And perhaps with Pig Latin. Maybe we'll get to see that. So I'm going to go ahead and clear this out. And let's take a look at our last two. Very similar, so I'm just going to sort of rope them into one. So our dot upper string method and our dot lower string method. Cool. So pretty straightforward. Let's just say I have a string. We'll just call this test, right? And it's just going to say, hi, my name is John. Okay, note the capitals, capital H, capital J. I'm going to print out test.upper. I'm going to print out test.lower. You guys should be able to figure out what these do. Very simple. So one of them has been raised all the way to uppercase for each letter. The other one has been raised lowercase for each letter. And there's one more that is actually very similar to these. It's test.capitalize. What this does is it takes the first letter and just turns that into a capital, because everything else is lowercase. Again, great for string manipulation. I can't think of a great example because this is pretty straightforward what it does. So yeah, dot upper, dot lower, and I guess I should add dot capitalize since I brought that up. Dot capitalize string method. Again, dot upper raises everything to an uppercase. Dot lower makes everything lowercase. Dot capitalize, I guess the best way to think of it is makes the first letter in the whole string capital, and everything else lower. Everything else lower. Simple. So, are we all good on our function and string method review? Any questions? You guys want to go over any of them one more time? Or shall we have some fun with some CodeWars activities? All good? All right, this is my most favorite part. I love working through these things. I feel like, I think 2 years ago, I started doing a lot of CodeWars stuff, and I just had a blast. I would like tell myself, okay, I'm going to try to do two of these little things, and I had a great time. So we've been doing a lot of 8s and 7s. So let's just warm up with a 7, and then maybe today we'll graduate into 6 and 5 territory. We'll see though. Let's do most popular. Those are always the best ones. All right, so we've done vowel count. Stop me if you guys see anything that like catches your eye by the name. Then again, I'm just gonna look until I see something that sort of has some nice topics that it covers. Oh, this is a good one. This is going to teach us a new function. Okay. I'm going to copy this, paste this into chat. That is the kata we're going to be working with today. So description. In this kata, you will create a function that takes a list of non-negative integers and strings and returns a new list with the strings filtered out. So we want to remove all of the strings. Let's do this. So we have, all right. So we're getting numbers, and we're getting numbers. So we have to remove the ones that aren't valid. Thoughts on this one? Let's brainstorm some ideas of what we think might be a good idea. What are we feeling, guys? No, that's all good. Actually, if no one has any ideas for this one, I'll give you one more moment because we're actually going to use this as an opportunity to learn one more, a new function. Maybe one more minute, see if you can toss out any ideas, no matter how crazy they are. And then we'll come into this REPL and I'll show you guys the new function I wanna expose you guys to. All right. I'll give you a sec. Maria, any thoughts with this one? Any ideas? Okay, let's hear it. Let's hear your wild idea, Luke. Again, you can also put it in REPL, and I know you follow me, so I can open up your REPL as well. So we can try that out. But let's hear it first. Use a try and except to pass a function that can only be done to integers to weed out strings. Would that even work? Let's think of a function that only works with strings. What you could do, it doesn't necessarily have to be a function. Let's talk about the idea. Let's open it up. I don't know if I've ever discussed try and excepts. And I probably won't, but let's talk about this. So if I have a try and except, and I want to basically only have, so again, let's bring it in here. Say test values, right? Throw in some numbers in there, right? And it'll test out some strings. Cool. What we're gonna do is let's have an empty list, so we have valid ints. For test value in test values, just print those out. Everything's working. Perfect, everything is working fine. What I'm going to do is I'm going to say try test value plus 10. It doesn't really matter what it is, plus whatever. Actually, let's just do that. R is equal to test value plus 1. So I get a type error. So again, I can do try test value plus 1, except if I get a type error, then I'll just pass. If this works, then what I can say is valid ints append test value. Now if I do this, no error. So if you go ahead, come down here, print valid ints, we get all of the ones that are valid. Now, Luke said we can use a function to do this, but it's even simpler. Again, you can't add a string and an integer together. You can only add an integer and an integer together. Or we can add an integer and a float. But we know that we're only given integers and strings, so we don't have to worry about the whole float thing. So again, if this works, that means I have to be working with an integer, and then I can add it to my list. So yes, this is actually very good. This is really good. I'm not gonna lie, it's kind of impressive that you thought about this. But there is an even better way of doing it. We have a function here, and let's save this. This is actually pretty impressive. I'll just comment that out. But what I'll do is I'll say for test value in test values, print test value, right? I'm trying to print out the number. And then I want to also print out is instance test value. Again, I'll explain this. Just give me a sec. Int. So what this is telling me is this 1 is an integer, this 2 is an integer, this 43 is an integer, this 3 is not an integer, right? False, and this 928 is also not an integer. So let's isolate this. Is instance. This is a new function we're going to be looking at. Is instance. Now, this takes 2 arguments. It takes in the object you want to test and the type you want to see if it is. So I want to see, is my test value an integer? I could very well have done the same thing with string to see if they're strings. The first 3 should show as false, and then the last 2 should show as true. If I put float, then all of them should show as false because none of these are floating points. So this returns true or false. And again, it takes the object that I want to test, and then the second thing is the type that I want to see that it is. So let's come down here. Again, we have this list, right? L is our list, and we'll just say valid integers. So we'll say for item in L, right? L is the given list. If is instance item int, right? Let's put those around. Valid integers dot append item. I'm going to return valid integers. Let's test this out. Again, my little camera box covers that, but it's right here on your screen. It should be on the bottom right. So we test it out. All of our test cases work. If we attempt, all of our attempt cases work. So do we have any questions with this? Is instance is pretty straightforward. And I'll just write a little brief description of it. Returns true or false if an object or variable or whatever it is the type of what is passed. Basically, I'm saying, hey, Python, is it true that this test value is an integer? Python will either say yes or it'll say no. So that is our isInstance function. And again, let's go ahead and submit this. Take a brief stroll through everyone else's answers. And again, people are using something called list comprehension, so their answers are significantly shorter than ours, but they're basically doing the same exact thing. So don't worry about these too much. I'm saving list comprehensions for another time. But pretty cool. New function added is instance. All right, so let's do one more 7. Oh, go back to our solution. Where is it? This is my solution down here. So again, if I go through this line by line, I'm creating an empty list. I'm going through every item that I've been given in my argument. If it's an integer, I'm going to add it to my valid integers list, and then I'm just going to go ahead and return that. Pretty cool, right? And just let me know when we're good to move on. Good to go. Awesome. So again, we've taken a look at this. Let's go ahead and move on to another one. Go back to the practice tab. We'll do popularity. We'll do 7KYU. Oops, 7. Again, stop me if you see anything interesting. I'm trying to find something where we can sort of like now use the things we've learned. Anything catching y'all's eyes? Friend or foe, find the next perfect square, printer errors. Oh, the DNA one. Let's take a look at that. I saw that. Where was it? I'm going to have to command F, DNA. There it is. Complementary DNA, strings and fundamentals. Okay. Train. So deoxyribonucleic acid, DNA, is a chemical. I don't know why I just said that. Deoxyribonucleic. I said it right. Deoxyribonucleic acid, DNA, is a chemical found in the nucleus of cells and carries the instructions for the development and functioning of living items. And they've kindly sent a Wikipedia article about DNA. We'll skip that. In DNA strings, A and T are complements of each other as C and G. Your function receives one side of the DNA. You need to return the other complementary side. DNA strand is never empty, or there is no DNA at all. So what they're saying is, again, I'm not a bio person, but just to clarify what they're saying, and maybe if you guys are thinking about it, you can help me out here. I'm more of a chemistry physics guy. But we're going to get a strand, right? A, T, T, G, C. Now, A and T are complements, and G and C are complements. So on one side, I have A, T, T, G, C, and then I want the complements on the other side. So I want A to be compared with T's. I want the two T's to be paired with the A's. I want the G to be paired with the C, and I want the C to be paired with the G. Does that make sense? Are we all okay on what they're asking us to do at least? Because again, it's kind of weird. Oops. Okay, so we're all good. Again, what are we thinking? This is tough. But I'm going to go ahead and open up so you guys can take a look at all the functions we have. Maybe one of our functions might be able to do the trick for us. And I'm going to clear this. Take a second, go back and forth between the prompt and the functions we know, and see if we can, what we can do with this. And I'll give you guys a minute or two to do that, just to get some thought, juices going around. Luke suggests dot replace. Personally, that's what I was thinking as well. Yeah, I think dot replace is a good one. In another world, you could also use like map, make a function that returns, but then you have to turn the whole thing into a list. So I think dot replace is definitely the better function for us to use on this one. And I think what we can actually do is just chain the whole thing together. And a dictionary idea is not bad. I mean, again, still valid. So let's have DNA. And actually, I'm just going to bring this into REPL. I like doing these things in REPL because it's bigger. So let's just have a test strand. And it's going to be, we use this as our example. Oops. Given ATTGC, we want to return TAACG. So I'll copy this first part. That is as a string. So we can chain our dot replaces together. So what I'm going to do is because there's four things that we have to replace. We have to replace the A's with the T's with the A's, the G's with the C's, and then the C's with the G's. It's so weird. So I'm going to say R is equal to test strand dot replace all of my A's with T's. Right? I print out R now. Oops, test strand. Cool. But then if I say, Q is equal to test strand is equal to R, because we're just sort of chaining these together, that replace T's with A's, and then I print Q. Look at that. That's not what our output should look like. So bit of an error there, right? And honestly, there's really no way to get around it. If I chain this, right, add this to the end of this, and I print R now, so we get AAA. We should get TAA. So Luke was actually right. A dictionary would be a good idea for something like this. So basically, Maria, I'm pointing out a problem with us using dot replace. And the problem is that if I replace all my A's with T's, right? All our A's with T's, but then I replace all my T's with A's, I'm messing up my output. I'm not getting the string that I need. Does that make sense? What the issue I'm sort of pointing out? Do you guys see what problem we might be facing with this? Okay. So yeah, let's try what Luke said. Let's try using a dictionary, right? Because that tells us what one thing should go to another thing. So we'll call this DNA. Or we'll just call this pairs, right? DNA pairs. So we know A goes to T, T goes to A, C goes to G, and G goes to C, like that. Pretty straightforward. Actually, let me copy this because I forgot to save the output. Yeah, there we go. We still have our test string. Now, what I'm going to go ahead and do is I'm going to say for pair, actually not pair, for base, because these are all DNA bases. For base in test strand, print base, right? So now that I do that, I get my A, I get my T, T, G, C. Now, if I do pairs, then pass in the base as a key, then I get T, A, G, C like that the dictionary has given us. Does that make sense what I've done here? How we're using the dictionary and then the given test strand to pull out the complementary pair. Okay. So what I can do is I can have complementary strand. I think this is an empty string, right? And what we'll do is we'll say complementary strand equals this. So we're just adding this on to the end of our complementary strand. So I go ahead and print complementary strand. You get TAACG. Bingo. So I'll give you guys a second to copy that. And while you do that, I'm going to copy this and bring it into CodeWars. Let's indent that. And we have to return complementary strand, and then test strand should be DNA. That's what's given to us. Cool. How do we feel about this? All good? Does it make sense? Again, if I test this out, works in my test cases. If I attempt it, it works just fine. So this gets the job done. Frankly, I'm interested in seeing how other people approach this. But just let me know when I'm good to submit if you guys are done sort of copying this. Oh my god, it is raining so bad outside where I am. Like, it is pouring. Okay. So I'm going to go ahead. Let's go ahead and submit this. Here it's summer till end of October. That's awesome. Oh, that's awesome. Interesting. DNA.translate. Make translation. It's a solution I haven't seen before. Oh, this is a cool solution, actually. This is actually very interesting what they've done here. This is something that we know how to do. I mean, again, this is a list comprehension, but it's still pretty cool. So basically, you make a list with all the pairs, and then you just join them together, which is pretty awesome. Some people did it like this, very similar to what we did, but we had our dictionary. This is interesting. This uses a string library. I have not seen this before. But again, people are basically using list comprehensions for all of these. Go back to solution. Let's take a look. Actually, I can just pull up the REPL. Or if you want the actual thing, I can pull that up too. Here's the actual thing. Make sure your indents and everything are right, I guess. That's always worth checking out, because sometimes when you copy over, the indents get messed up. Oh, God. I have a question for you guys, actually. It's about teach, not really coding. When you sort of, how do I word this? When you guys like sign up for my class or like a lesson, do you guys get like a reminder in your email or something? like 5 minutes before I start or something, or it's just have to like remember that you signed up for my class? Like you get email reminders like the day of, or like 5 minutes before I start. I have to sign up to get a reminder. But do you get, I know you get a reminder, like an email when you sign up, like this is, the lesson, but for each class, okay. But do you get a reminder the day of? So let's say you sign up on Wednesday, right? You get the email confirming your lesson. But on Saturday, when I have my lesson, do you get an email then as well? To like remind you, oh, don't forget, you have a course to, or a lesson to join in on today. Because the issue I've been having, and on the day like an hour before, okay. Because the issue I've been having is I have people, sorry, this is sort of like off topic, but I have people signing up for the class and I see, 40 people have signed up, but then it's just the two of you guys. I'm like worried. Are people not remembering? Are people not getting reminders? I'll have to ask. I'll have to ask the folks that teach to look into that maybe. But let's continue on. I think we're all good. Let's graduate. I see 4 people active, but yeah. But interestingly enough, for this lesson, I had 44 people sign up. Like on my attendance list, I can see who signed up for the lesson. I had 44 people signed up. Kind of crazy. But let's move on to our 6KYU. Let's try picking one of the easier ones, right? Instead of one of the more popular ones. Actually, no, let's do the popular ones. They're definitely better. Yeah, I'll have to ask about that. Yeah, okay. Thanks, guys, because I wasn't sure about that. Again, stop me if you see anything interesting. I'm particularly drawn to the sum of digits because I feel like we can get a good usage of our sum function. So I'm actually let's try that out. Let's read what it is first before we start training on it. Digital root is a recursive sum of all of the digits in a number. Given n, take the sum of the digits of n. If that value has more than one digit, continue reducing in this way until a single. Okay, what? Oh, so this is a recursion. Never mind. We're not going to look at this just yet. Let's try this. Multiples of 3 or 5. If we list all the natural numbers of 10 that are 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Finish the solution so that it returns a sum of all the multiples of 3 or 5 below the number passed in. Additionally, if the number is negative, return 0. Okay, so let's train on this. This one seems interesting. And again, this will be our last one. I'm not feeling too well, so I don't think I'll be able to make it for the whole hour 30. So let's do good on this one and wrap it up. So basically, I'm given the number I go up to, and from 0 to that number, I have to find all of the multiples of 3 or 5 and then add them all together. Cool. So again, if my number is given to me as 15, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, right? I have all of these numbers. Now, which ones of these are multiples of 3 or 5? 1 is not a multiple of 3 or 5. 2 is not a multiple of 3 or 5. Oops. 4 is not a multiple of 3 or 5. 6 is. 7 is not. 8 is not. 9 is. 10 is not. 11 is not. 12 is. 13 is not. 14 is not. I have 3, 5, 6, 9, 12, 15. If I add those up, I get, 3 plus 5 is 8. 8 plus 6 is 14. 14 plus 9 is 23. 23 plus 12, 25. 25 plus 15 is 40. So 40 if I add it right. That's what we need to do. And again, if we're given a number that's negative, let's say they give us like -1, then we automatically just return 0. Right. Let's see if they have any test cases for that. Yeah. So -1, return 0. So what we can do is the first thing we should check for is that negative number, right? We just want to get that out of the way, not have to worry about it. So what we could say is if number is less than 0, return 0. Or if it's even less than or equal to 0, we can return 0. Because again, if you have 0, it's not a negative number, but you're still not going to get anything out of that. Now, what I can say now is for I in range of numbers. Now this is going to take me from 0 all the way up to that number. So this is going to take us up to, but not including. So I have to add 1 to it, right? Because that final number also has to count. Does that make sense? So take that, and we're basically going to say if I is divisible by 3, and that's equal to 0, or if I is divisible by 5, that's equal to 0, right? That's the multiples. If any of that happens, right, if it's either divisible by 4 or 5, we're going to have a list called this valid multiples, right? We'll say valid multiples dot append I. Let's test this out. Return valid multiples. Oof. Oh, I have to return the sum of it. Oopsie doopsie. Test this out. Oh, so it looks like we have a little error. Should return 8 for when n is equal to 6. So again, if number is given to us as 6, we have 0, 1, 2, 3, 4, 5, 6, right? 0 and 1 are not multiples of 3 or 5. 2 isn't. 5 isn't. Oh, so the issue I think we're having is we don't have to add this plus 1. Because again, if we get out of the 6, then we'd have 8. But if we leave the 6, then we're getting that 14. My bad. I guess I misread that. Now if we test it out, there we go. Makes sense. Works out. I'm going to attempt it. Cool. It works out here as well. So what are we doing here? Yeah, let me go ahead and explain it because I went through this kind of quickly. The first thing I did was that the prompt said that if I get a number that's negative, right, I have to return 0. So if my number is negative or it's equal to 0, I'm just going to go ahead and just straight up return 0, right? I just want to get that out of the way. Now, the second thing I'm doing is I'm going to create a list of all the valid multiples. So again, if you remember how I had, like, when I was doing num equals 6, I had that 3, I had the 5, right? I want this list to be where all these valid multiples get saved. Now what I'm going to go through is I'm going to take all the numbers from 0 to the number I'm given, and I'm going to see if any of the numbers from there to there are valid multiples of 3 or 5, right? That means they can be divided and they have a remainder of 0. Then that means they're a valid multiple. And I can add them to my list. Then all I have to do is just sum them all up, and I can do that using the handy-dandy sum function. And then I'm just going to return that out. That makes sense. Let me comment this out. Or sorry, not comment. Let me get rid of this. How do we feel about this one? Yeah, first KYU, right? Pretty awesome. I'm actually going to go ahead and wrap it up there. I'll give it a minute or two if you guys have any questions. But I do have some homework for you guys. Not really homework, but just something I want you guys to take a look at because I think it might be interesting. So you've probably heard me mention all these list comprehensions whenever, when I submit and we look at the other people's answers, right? We see all these list comprehensions like this. What I want you guys to do is actually do some research about it. Read into list comprehensions, because tomorrow we'll talk a little bit more about them. And I think tomorrow we'll spend most of our time on those list comprehensions, and then we'll worry about working on more CodeWars stuff, because list comprehensions are pretty powerful. They let you create lists in one line, so pretty dope. Again, we'll see how I'm feeling. I have 2 lessons for tomorrow. I have the review lesson, and then I have this lesson where I'm showcasing some of the projects I've made. So feel free to join both of them. They're both up. You can, set the reminders and whatnot. But until then, guys, take care, be safe, wash your hands, practice. It's the most important thing. Yeah, I need a break. But yeah, thank you guys so much for another wonderful lesson. Thank you for the questions. And hopefully, I really hope I'm feeling okay by tomorrow. But we'll see you guys tomorrow. Take it easy, be well.